Hello there and welcome to a brand new lesson. This is how Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at graph of parabolic functions. By the end of this lesson, you should be able to draw a graph of quadratic function using a table of values. You should be able to sketch parabolas using key figures such as the vertex, the intercept, and the axis of symmetry. You should be able to describe transformations of y equals x squared. You should be able to read and interpret key information from a parabola's graph. And finally, you should be able to identify the range of quadratic functions from its graph. Here are some key vocabularies I would want us to look at before we proceed in this lesson. So let's first of all start by looking at what we call the parent function. Now I'll display this graph here so that I'll easy to explain, and then you'll be able to understand and then have a graphical concept of what we are doing. So this particular graph we see here is what we call the parent function, and its equation is what? Y equals x squared. Y equals x squared. Now for this parent function, it is the basic parabola with vertex at the origin. So if you look at the vertex of the parabola, it is at the origin. You see, this is the origin, and it opens upwards. Now any other quadratic function derives from this. All the other ones are just transformation of this basic one. For instance, if I'm to move all these parameters here, you see we'll get different graphs. You see, it moves to the left and then to the right and then even up and then down. So any other graph at all you can ever think of are from this particular one we call the parent function. And the parent function is y equals what? X squared. Now, if this parent function undergoes a vertical shift, if it undergoes a vertical shift, what do we mean? So first of all, we have what we call the vertical shift. The vertical shift. The vertical shift is simply adding or subtracting a constant c. And when you do that, it shifts the parabola up or down. So as an example, we are saying our parent function is what? Y equals x squared, right? So if we decide to add a constant, if we decide to add or subtract a constant to this parent function, that is either a y equals x squared, so let's take plus 3, so plus 3, or y equals x squared minus 3. Let's see what is going to happen over here. So in that case, we are simply saying for vertical shifts, if the parent function is supposed to shift vertically, then it should undergo y equals x squared, then plus or minus c. And we are taking the c to be what? 3. So we are doing a plus 3 and then a minus 3. Then we see what our result is going to be. So for plus 3, look at what happens. Look at where plus 3 takes me to. You see that it has moved the parent function all the way up. Initially, the vertex was at the origin, but this time around it has moved the vertex towards 0, 3. You see that? So what if, let's come back to the parent function. What if I actually use minus 3? So for minus 3, let's look at what is going to happen. So minus 3, and coming all the way down to minus 3. Look at what happens. It shifts the parent function downwards. You see? So that is to say that if our constant c is greater than 0, as you saw over here, the parent function is shifted upwards. If our constant c is less than 0, the parent function is shifted downwards. This is what we call the vertical shift. And as much as the parent function can shift vertically, it can also shift horizontally as well. And what accounts for the horizontal shift? The horizontal shift occurs if, when you have y equals x squared, you actually want to change the value of x either to the right or to the left. So that instead of the x, you are writing y is equal to x minus h, you see, or y equals x plus h, you see. So if you are using minus h, this time around, let's take 2. So y equals x minus 2. So if you are reducing x by 2, what is going to happen? And if you are also increasing x by 2 as well, what is going to happen? So trying to illustrate these two on the graph, let's use x minus 2. So for x minus 2, look at what is going to happen. You see, so as I'm increasing the number here, look at what is actually going to happen. So from x squared, then we go to minus 0.2. You see it has moved to the right hand side. Minus 0.4, it is moving to the right hand side, and it goes all the way till I get to my minus 2. You see, so this is one transformation the parent function goes through. That is, if you are rewriting it as y equals x minus h, if it is minus h, then you are transforming it to the right. Don't be confused. If it is minus, you are transforming to the right. But then if it is plus, so look at this here. You see, as this is plus now, our parent function is being moved to the left. You see, so it's like the opposite of the number line. If it is plus, it is going to move to the what? To the left. And if it's minus, it is going to move to the right. The real explanation behind this will be understood when we study completing of squares. So don't worry about this. You can check the playlist where we have dealt with completing of squares to enhance your understanding of this. Now there is one last form we need to consider. That is the vertex form. So the vertex form of writing a quadratic function is what? Y equals a into bracket x minus h all squared plus k. If you're able to write a function as this form, then you'd always get your vertex being h, where h is the x coordinate, and then k, and k is also the y coordinate. So what do we mean by that? If you are able to write your parabolic function or your parabola in this form, you'd always get your vertex just by looking at the equation. Just as we can straight away tell the gradient of a line when we take a straight line, or the y-intercept when we take a straight line, the same way, if you write a function in this form, you can easily tell its vertex. And it is very, very good for graphing than the standard form. Now, the next term we need to consider is what we call the range. So the range is simply the set of all the y values the function can output. So for a parabola, the y is greater than k when it is a minimum function, and then y is less than k when it's a maximum function. So we said we can rewrite our function as y equals a into bracket x minus h all squared and then plus k. And we said the vertex is simply what? So the vertex is simply h k, right? So this k over here is also the range. It is used to solve for the range of values of the y. So that if I have a function such as, let's say, y equals x minus 1, then you have your squared plus 3. Then that is to tell you, first of all, that the range of values of y is what? 3. And in this case, a is positive. We know if a is positive, then it always has a minimum value. So that is what I have graphed over here. This is the graph of y equals x minus 1 all squared plus 3. So you realize that by looking at the graph, we even have our vertex as what? 1, 3. And that is what we have here. So 1 and then 3. That is the vertex. So the vertex is what? 1, 3. But talking of the range, for the range, we are looking at the set of all the y values. Now, if I'm to zoom out of this, you realize that the function even goes on and on and on, you see. So even if I move up, you see that it still goes on and on and on. Now, if I'm to move down, you see the function ceases to continue down here. So it means the accepted value of y is simply any value from 3 upwards. You see, so by looking at our function, we can say the range of y values is simply what? Any value that is greater than or equal to 3. Now, if we were to have our function written as y equals x, then this time around, let's use minus 1 plus 2. Let's make our a negative. This is a downward function because of the negative here. If I'm to illustrate it here, then this is how it's going to be. So with that, once again, our vertex is then going to be what? 1. So we have 1 and then 2. So 1, 2, and then we have the range of values of y. So this time around, you realize that the parabola or our graph doesn't extend to any value above 2. It ends at 2 and then it continues downwards. So you can say our y is simply what? Less than or equal to 2, because 2 is its maximum value. That is the range. Now, when we talk of the turning point of the function, it is simply the vertex. It is another name we'll be using in place of the vertex. So that is all for the vocabularies we'll need for this course or this session. So now that we've gone through all the terms, let's quickly look at these quick notes and then this as well. And then we can look at how we can actually draw our own graphs using the points. So first of all, we said y equals x squared is simply the parent function. And if y equals x squared is being increased by a k, then it will cause the parent function to shift graphically. So when the k is greater than 0, then it's going to shift up. But then when the k is less than 0, the shift is going to be what? Down. Also, if you have y equals x minus h all squared, and then you are changing the values of h, then if h is greater than 0, you are going to shift to the right. And if h is less than 0, you'll be shifting to the left. And then we have y equals ax squared. That is the parent function being multiplied by a. Now, depending on the value of a, the parabola stretches. So with that, as you can see over here, this is our parent function. So if I increase my A or decrease it, you see what happens? It stretches, it widens, or it compresses. See? But immediately as we take it to the negative domain, so if I take my parent function and I make the coefficient -1, for -1, let's look at what happens. So -1 would just move it all the way to the other side. So something like this, you see. So this is -0.5, -0.7. But I want a -1. So this is how it's going to be, you see, opposite to the parent function. So the parent function is actually this, you see. But then if we change it to negative, you see what happens. It gives us the opposite altogether. So that is that. And then we are also saying that the vertex form is the most useful form when it comes to your graphing of quadratic functions, because you can easily tell what the center is. That is just by looking at your k, your h, and then your k, you can tell what the center is. You can also tell the axis of symmetry, and then you can also tell whether it is a maximum or a minimum function. For now, we have to take this particular equation as it is. When we come to completing of squares, we'll get to know how they are proved as well. So in our introduction, I told you we'll be learning how to sketch a parabola. Now, when it comes to sketching of parabola, there are 5 key points we need to take note of. So anytime we have a parabola, then we need to be able to determine our vertex. So if you have y equals, let's say, you have your a x squared, then plus bx and plus c. Then if you want our vertex, you take note of your a, you take note also of your b, and then you just say your vertex occurs at x equals negative b over what? 2a. And since vertex are coordinates in terms of x and y, you'd have to substitute this value of x into your function. So if this was simply a function of x, then all we need to do is to find f of where it occurs at, that is at negative b over 2a. And that is going to give us the coordinate of what we have as the vertex. Secondly, for y-intercept, even from linear equations, y-intercept is simply where we have x to be equal to 0. You see? So if you want your y-intercept from y equals ax squared plus bx plus c, it is simply y is equal to what? C. That is, if you substitute x to be equal to 0, this is going to give us 0, and this as well is going to give us 0. We have all this giving us 0. You see 0 plus c. This becomes our y-intercept. Then for x-intercept, on the other hand, you are going to set y to be equal to 0. So if you have y equals a x squared plus bx plus c. So for x-intercept, we set our a x squared plus bx plus c to be equal to 0. For this, you can determine the x values graphically using factorization method, that is the AC, or completing of squares, or the formula, which we'll be looking at in our subsequent lessons. You should also take note of the symmetry, that is the line of symmetry. So mostly, this is what we call the line of symmetry. So the x coordinate is used to form an equation, and that becomes your line of symmetry. If you're able to get all of this, you can easily be able to make any interpretations from your graph, either it being in a U form or an N shape form. With that said, let's solve some questions to enhance our understanding. So let's start by looking at our first question. A very simple one, and we'll build on it as well. So our first question says copy and complete the table of values for y equals x squared minus 4 and state the vertex and range. You have to copy and complete, so we are just completing this table. Now, anytime you are given this question in exam, then all they are asking you to do is to substitute each values of x into your y, and then you complete the table. So you know your function f of x or y is simply equal to what? X squared minus 4. So you start by using your first value. For x equals -3, and y then becomes, instead of the x, you are going to put what? A -3 there. So -3 all squared, then minus 4. So we have our y being equal to a -3 squared, then gives us a 9. So we have 9 minus 4. And 9 minus 4 simply gives us a 5. Then we come to the next value, which is what? -2. So you say for x equals -2. So we have our y being equal to, instead of the x squared, we are going to put the -2 all squared, then minus 4. Substituting, we have what? Our y being equal to -2 squared is 4. So 4 minus 4, giving us our y, which is equal to 0. I'll do to the 1, and then I would expect you to also do 1, 2, and 3, and then give me the answers in the comment section. So we have for x being equal to -1. So we substitute x for -1. Hence we have our y, which is equal to, instead of x squared, we have -1 all squared, then minus 4. -1 squared gives us a 1. So we have 1 minus 4, which then gives us a -3. Then for the last one I'll be doing, we say for x is equal to what? 0. So if x equals 0, you have y, which is equal to a 0 squared minus 4. Hence our y is equal to what? A -4. So filling out our table, for -3, I have my 5. For -2, there is a 0, right? Then for -1, we had a -3. For 0, we had -4. Now, if you were able to solve for 1, 2, and 3, then for 1, you should expect an answer of -3. For 2, you should expect an answer of 0. And then for 3, you should also expect an answer of 5. So this will be the completed table. Now it says we should state the vertex and the range. We know how we get the vertex. So the vertex can be gotten in 2 ways. So first of all, we know what the equation is. The equation that was given us was y equals x squared, then minus 4. If you have to write it as the standard equation, we know the standard equation is simply y equals ax squared plus bx and then plus c. And we always said that what? The coordinate of our vertex is simply, for the x coordinates, it is what? The -b over 2a. And then for the y coordinate, we have your function with this value of x, which is -b over 2a. From here, we know our a is equal to, so comparing it to what we have here, mind you, our y equals x squared minus 4 can be written as what? X squared, then plus 0x, and then minus 4. That is writing it in the standard form. So that with that, we can easily say a is equal to 1, b is equal to 0, and then c is equal to -4. That is comparing. A is the coefficient of x squared, B is the coefficient of x, and then C is always your constant. So with our x, it's simply what? Negative b, and our b is 0. So 0 over no matter what we have at the negative, that is 2 times 1, we are still going to get 0. Then with that, we find f of, so remember, after getting the x, we find the function in terms of the x. So f of 0. From the table, we know what f of 0 is. F of 0 is negative 4. So it simply means the vertex is what? 0, negative 4. That is our vertex. And you see, you would have easily been able to tell from your table, but it is not always safe. For this, you could easily tell it was 0, negative 4. But to confirm and then be sure of your answer, I would always prefer you solving it out. Now, the second part says we should state the range. We should state the range. For the range, if we have our vertex at 0, negative 4, the vertex also tells us this was actually a minimum function, right? So it tells us the least value y can be, you see. So hence, since the parabola opens upward, then it simply means the values of y are greater than or equal to negative 4. And that becomes our range. You see, we said we can get our range from even the vertex, because the vertex represents the lowest or the highest value the function can ever get. So that will be it, and our conclusion will be the vertex is 0, negative 4, and then the range is y is greater than or equal to negative 4. That is all y values at or above the minimum. That is it for our first question. Now, before we go to the next question, let's try and then plot these points out to see if we can confirm the vertex and then the range, and even look for the axis of symmetry as well. So from our table, for us to be able to see it, I'm bringing it here. And then now let's go to the graph sheet. So on our graph sheet now, let's identify our points. We are identifying the coordinates on the graph sheet. Our first one being what? Negative 3, 5. So these are my points, and then on the x-axis, we move to negative 3, and then on the y-axis, we move to 5. So negative 3, 5 is going to be here. You see, so negative 3, then up to negative 5. You see, negative 3 up to negative 5. Then we come to a negative 2, 0. So on our negative 2, we don't move. You see, because on the y-axis, it says 0. So we are going neither left nor right, up nor down. It should be just as it is. For negative 1, for x equals negative 1, we have y being negative 3. So x equals negative 1 will come down to y being negative 3, and that is this point here. So I'm bringing my point right here. Negative 1, 3. You see? Then the next one says 0, 4. So at x equals 0, 0, negative 4. So at x equals 0, y equals negative 4. So we bring that point as well over there. Then we have 1, negative 3. So 1, negative 3 comes up here. And then we also have a 2, 0. So 2, 0 is also right here. And then 3, 5. So 3, 5 also comes up right here. So what we are left to do now is to draw our curve through this, you see. Now, you don't necessarily have to make sure everything is perfect. It is always a sketch, you see. So if you are using your free hands, then you can easily take your time and then draw through all these points, you see. Then this will be our graph. But then I'm coming to use my tool so that it becomes more clear for you to also see and then do it as well. So if I'm to use my tool to do it perfectly, this is how it is going to be. And as you can see, we can identify all the necessary points. So first of all, we have what we call the x-intercept. So this point here is our x-intercept, you see, where the curve touches our x-axis. So this point and then this as well. Then we have this point being our minimum value, the minimum value. And for this particular one, the y-axis is actually our axis of symmetry. And it is also called the line x equals 0. And then this is our function. So if I'm to label, then down here is simply my vertex. And the vertex coordinate is what? 0, -4. Then this side is what? My x-intercept. So the x-intercept. Then this is simply the function. So the function was x squared minus 4. Or you can write it as y equals x squared minus 4. And this here is our axis of symmetry. That is the line x equals 0. So axis of what? Symmetry. So that is all for this graph. That is if we were to plot it out as you see. With that said, let's look at our next question. Our second question we have here says we should describe the transformation from the parent function, that is y equals x squared, and then it transforms all the way, first of all, to our a. A is y equals x squared minus 5. Now, if you look at this transformation, it is described by what? Y equals x squared plus or minus k. And we said when it is this form, it simply means it is moving either up or down. So it is moving up if the k is positive, and it is moving down if the k is what? Negative. By observation, our k is -5, which is a negative value. So it simply means it is shifting downwards. You see, so this transformation is a vertical shift, 5 units downwards. You see, so it simply means, you know, our parent function's vertex is what? 0, 0. You see, so if we are saying it is moving it downwards, then it has moved from 0, 0 all the way down to what? 0, -5. You see, so our transformation is what? Vertical shift downwards 5 units by 5 units. That is fine. Okay. Then let's look at the second one. For the second one also, we have our parent function, that is x squared, is being transformed to what? B. And B is giving us y equals x plus 3 all squared. So remember the transformation we did earlier on. We said if y equals x plus or minus h all squared, where if it is plus h, then it simply means it is moving to the left. If it is minus h, then it's moving to the right. And I said this shouldn't confuse you. It's just the opposite of the number line. So this time around, we have what? Our h being plus 3. So our h is simply what? Plus 3. So what is happening? There is a horizontal shift 3 units to the left. And once again, we know for the parent function, its vertex is 0, 0. So if you are saying it is moving 3 units to the left, then it is moving from 0, 0 all the way towards negative 3, 0. You see? So we can say, therefore, it is moving 3 units left. As simple as that. Our last transformation here is simply what? So we have our parent function, which is y equals x squared, has been transformed to what? Y equals negative 3x squared. Remember, we said if there is a number multiplying the parent function, then that determines how wide or compressed it is. When I illustrated that graphically, we saw it. If it is a number, just a number, it shows how wide or compressed it is. But then if it is a negative, then it is simply a reflection. You see, it is simply a reflection. So in this case, we have negative 3x. So for 3, then we can say that it has been narrowed and reflected. So for this particular one, let me illustrate it on the graph so you see. So first of all, this here is our parent function, you see. Now if this is our parent function, we are choosing to multiply it by 3. So if I multiply it by 3, look at what happens. So initially, it is just like this. Look how wide it is. But if we move a to 3, that is parent function times 3, it becomes narrow. Not only are we multiplying it by 3, but we are multiplying it by negative 3. So negative 3, you realize that it moves all the way to the opposite side. It is reflected. You see? So that describes the transformation we see over here. So with that, we can say it has been what? Reflected and narrowed. It has been reflected and narrowed. As simple as that. That is the description of this transformation. So that is it for question number 2. You see, learning the terms was very, very important because as you can see, we are actually applying them here to answer these questions. Our third question. It says we have to sketch f of x equals x squared minus 4x plus 3 by finding the vertex, the intercept, and the axis of symmetry. How do we go about this? We know what our function is. So we know f of x is equal to x squared minus 4x plus 3. And if you are to compare it to the standard, then our a is equal to 1. That is the coefficient of x squared. Our b is equal to negative 4. That is the coefficient of x. And our c is equal to 3. So we have all of these. Now with all of these, we can then find the vertex, the intercept, and the axis of symmetry. So for the vertex, we know the vertex has 2 coordinates. And before we do that, we need the x coordinate, and then we can then substitute to get our y. And how do we get the x? That is the same as the axis of symmetry. So let's first of all get our axis of symmetry. So for our axis of symmetry, we say our x is equal to a negative b over 2a. So substituting, we have our x, which is equal to the b, which is negative 4. So negative 4 over 2a. Our a is 1, so 2 times 1. This gives us an x. Negative times negative gives us positive. So we have positive 4 all over 2. And hence our x is equal to what? 2. So if x is equal to 2, then if you want the vertex, then we are actually solving for f of 2. And f of 2 is simply what? X squared, which is 2 squared, minus 4 into bracket, your 2, then plus 3. This when evaluated gives us 2 squared, which is 4, minus 4 times 2, 8. So 4 minus 8 plus 3. That gives us a negative 1. So it simply implies that our vertex is simply what? The x coordinate is 2, then the y coordinate is negative 1. This here is our vertex. We now come to our intercepts. So for our intercepts, there are two. We have the y-intercept and then the x-intercept. So let's start with the y-intercept. Now at y-intercept, then we are looking for x being equal to 0. And if x is equal to 0, then we find our f of 0. That is the function when x is equal to 0. So we have 0 squared, then minus 4 what? Into bracket 0 plus 3. That gives us a 3. So our y-intercept is simply what? 0, 3. This here is our y-intercept. The next thing we need is our x-intercept. So for the x-intercept, then it simply means our y is equal to 0. And if our y is equal to 0, then it means the function f of x is equal to 0. Now this takes us to a domain where we are going to use any of the methods to solve for this equation. What is the equation? F of x. F of x is what we have over here. So we have x squared minus 4x plus 3 is equal to 0. That is solving quadratic equations. You can check the playlist where I have treated it and then you can revise on that. So for x squared minus 4x plus 3, we have the factorization method, the completing of squares, and then the formula. We use the factorization method when we can multiply our a by c and then find a product or the factor pairs of AC, which when we add will give us negative 4. If you have gone through the lesson, then it will be simple, and then we are just going to get an x squared minus x, then minus 3x plus 3 is equal to 0. If you are using a calculator, you can just punch it out and then get the roots. So after this, we are going to get an x minus 1. That is if you want to factorize, and then an x minus 3 is equal to 0. Solving for the x's, we have our x being equal to 1, and then x being equal to what? 3. So we can then conclude that our x-intercepts are what? X equals 1, and then x equals 3. But if you want them as points, then we simply mean the x-intercepts are at the points x equals 1, and when x equals 1, y is 0. And then we have 3, 0. Now there's the last thing we need to do. That is the axis of symmetry. For the axis of symmetry, we have already solved that. That was the x equals negative b over 2a. And then we had what? Our x being equal to 2. We've already done this. So do we have all we need for our graph? Yes, we do. We do have all we need to draw our sketch. Because first of all, we have the 0, 3, that is, we have the 0, 3, that is the y-intercept. and we also have 1 0. So I'm listing them in order. Then we have 2 negative 1. So 2 negative 1 was simply the vertex. And we also had a 3 0. We have these 4 points. Now if we have these 4 points, let's then go to our graph sheet and see if we can come up with a sketch. So with a sketch, let's start by first of all plotting out the points we have. You see, so for the first point, we had the 0 3, and 0 3 was simply y-intercept. So I'll take this point and put it in place of what? 0 3. So this is my 0 3. Very simple, right? If you have your graph sheet, you can also follow along. Then our next point we solved for were the x-intercepts. So the point where our graph touches the x-axis. So the first one was 1 0. So we move our point toward 1 0. Then we mark that 1 0. And then you also need 3 0. So I have my 3 0 over here. Now I need where my minimum value is going to be. And for that, we solved that to be what? 2 negative 1. That was 2 negative 1. So 2 negative 1. This is where my minimum value is going to be. So at least I have this point, this point, this point, and then this point. And you have to sketch through it. But remember, we had our axis of symmetry. Our axis of symmetry was x equals 2. So with that, you can draw your axis of symmetry to guide you in what you are doing. So I'm going to draw the axis of symmetry over here. If you remember, the axis of symmetry is very important because, you know, the axis of symmetry divides your parabola into 2 equal parts or 2 mirror images. So it simply means whatever I have at the left hand side over here, I can reflect it through my axis of symmetry to give me the opposite here. So with our minimum being the 2 1, we have 1 1 at the left hand side of our axis of symmetry. On the right hand side we have what? 3. They are all 1 steps away from the axis of symmetry. For this 3, it has what? 1 2. It has 2 steps away from the axis of symmetry. So if you want it on the other side, it's going to be what? 1 2, and that is going to be 4 3. So you see, with the logic of the axis of symmetry, we've been able to complete the curve. That is 4 what? 3. Now with all these points, let's try our best to draw our sketch. So you can just take your pencil and then with a free hand, you just draw this. So we are using a free hand. So you can just take your pencil and then draw your graph with a free hand. This is how it's going to be. Or I would use my tool here. So with my tools, this is how I'm going to do it perfectly. Now, if you are using your graph sheet, you shouldn't worry about making it so perfect. It is a sketch. It is just a sketch. So you just need to make sure you draw the sketch along the points you have identified. And you don't forget to what? Bring your axis of symmetry as well. So this is the sketch of our question number 3. And with that, we can come in right here that our axis, our minimum value. So that is to say our minimum value is this we have over here. And then our x intercept. So this point here, and then this point here are our x intercept. And then this is our y intercept. And then this as well is your axis of symmetry. So let me write them there nicely. So here are all the labels of what we need on this graph. So we'll end this lesson here, but as usual, I'll leave you with some exercises so you try on your own. So here are just 3 questions you can try your hands on based on all that we have done so far in this lesson. This is how Beyond Numbers where we learn maths the easy way. If this lesson was helpful, you can choose to subscribe if you haven't and you so do wish, so that anytime I release a video, you'll be notified as well. You can look on the playlist where we have the next lesson so that you can also learn along. See you in our next lesson, and bye for now. Do stay safe.